Hello, my name is Rudolf and I'm going to introduce you to the research topics and members of the Machine Learning and Data Management Group at SBA. Our overall goal is to facilitate privacy-preserving, robust and secure machine learning. To this end, we are advancing privacy-preserving data publishing methods, such as synthetic data generation, as well as anonymization techniques for complex data types, such as genetic data, always considering the privacy and utility of the resulting sanitized datasets. We further advance approaches that can utilize the unabridged data directly, with methods such as federated learning or secure multi-party computation. Machine learning systems must be robust and secure to be deployed in critical settings. Developing novel mechanisms to detect and defend against attacks to the machine learning process, such as evasion or data poisoning attacks, is therefore crucial. Moreover, it is necessary to protect the intellectual property used and created in the machine learning process. We address this, for example, by advancing watermarking and fingerprinting methods as a means to deter data and model theft. These activities are complemented by efforts to increase the rigor of data science processes. Our current focus is on providing machine-actionable data management plans to support the data analyst. In this field, we actively contribute to the Research Data Alliance and its working groups. Regarding our team, we are very happy to have a good balance between junior and senior researchers, with backgrounds in fields such as computer science, information systems, as well as mathematics. As a result of actively supporting female researchers, for example with the help of programs such as Femtech, we are also proud to say that we have a very good gender balance in our research group. The members of our team will now introduce highlights of their current research.
Hi, I'm Anastasia and I'm a PhD student. I'm working on privacy-preserving techniques in machine learning with focus on federated learning. Federated learning is an approach which allows us to train machine learning models on distributed data without explicit communication of this data. Imagine you have several medical institutions which want to train model predicting lung cancer, but they don't want to share their patients' private data. Federated learning allows them to train machine learning models locally at each institution and then just to share the trained models with federated server, which aggregates all local models into a new global one, which then shared to the institutions back for making the predictions. Currently, I'm working on evaluation of privacy and security risks in federated learning, as well as possible mitigation strategies.
Hi, my name is Tanya, and my research interests are privacy-preserving data analysis and intellectual property protection of data and machine learning models by mechanisms such as watermarking and fingerprinting. Regarding privacy-preserving data analysis, I'm mostly focusing on anonymity in datasets containing individual-level data. Anonymity techniques prevent the identification of personal data in such datasets. However, they usually decrease data utility, so we are also analyzing this aspect of anonymization. Watermarking and fingerprinting are techniques that are embedding the owner's signature inside of their property. The property can be data or it can be a machine learning model. These signatures also rely on slightly modifying the data, so data utility is again one important aspect that needs to be analyzed. All of these techniques have in common that if we want to increase their robustness, it would mean decreasing data utility. So the challenge is to obtain a good balance between those two.
Hello, I'm Tamara. I'm a junior researcher at SBA and I am working on adversarial machine learning, more specifically model inversion attacks, which try to infer information on the original data samples from a trained model. Further, I would like to evaluate such attacks in various settings and also design possible countermeasures to prevent such attacks. Thank you.
Hi, I'm Tomasz. My research focus is on methods and models to ensure trust in data and computational experiments that underlie scientific publications or business processes. Trust is especially important in the context of machine learning, in which data scientists build complex processing pipelines that consist of several software tools that process the data. To be able to audit and reproduce results of such experiments, we must not only be able to tell what data was used, but also what software in which version and what parameters were set to fine-tune these pipelines. Apart from reproducibility, that is one of the cornerstones of trust, we also need to do proper data management. And this means being able to tell what data was used, whether we were actually allowed to use this data, and later to make sure that results of the computations are fair, findable, accessible, interoperable, and reusable. Hence, solving challenges in this area requires working on different levels of granularity and very often cooperation with different domains.
Hi, my name is Markus and my research interest is privacy-preserving machine learning and synthetic data. The approach of generating synthetic data is applied to structured datasets. Think of a table where the rows refer to individuals and the columns are attributes such as gender, age, employment, or health information. Synthetic data generation tools learn the global properties of this table, the distribution of attributes, and the correlations between them. In the next step, they generate artificial records to build up synthetic data with similar properties. The artificial records do not represent real individuals, and there is no one-to-one correspondence between them and the original samples. The promise of this approach is its high utility for machine learning, while the privacy of the individuals in the original data should be protected. We have evaluated synthetic data with regard to both aspects.
Hello, I'm Andrea, and one of my research interests is natural language processing, in particular named entity recognition. If we're working with sensitive data but at the same time would like to preserve the utility of our data, entity recognition helps us automatically recognize which parts of the text are sensitive and need to be anonymized. Further, I also work with record linkage. Basically, we try to link the records of, let's say, two datasets to find if an entity is included in both of them. It is important mainly because even in datasets that were pseudonymized or anonymized, by comparing the attributes which were initially not considered to be sensitive, we might be able to infer some information about the records in these datasets. And this is something we, of course, want to prevent.
Hi, I'm Florencia, and I have recently started working at SBA as a junior researcher. And my research is focused on novel approaches to anomaly detection from distributed data sources via federated learning techniques.
Machine learning might become subject to adversarial attacks. For example, a malicious user might try to embed a backdoor into a learned model with the goal of forcing misclassification for specific data records. This can be achieved, for example, by a data poisoning attack. In our research, we therefore address the challenge on how to detect and defend against such attacks. This becomes an important aspect of protecting the integrity and the availability of systems that depend on machine learning, for example, autonomous vehicles. We specifically consider settings such as federated learning. While on the one hand, this offers an increased level of the protection of the privacy, it on the other hand becomes more vulnerable, as it opens up novel attack surfaces a malicious user might try to exploit. This is because the learning process becomes a distributed process. We need to adapt detection and defense mechanisms to this distributed setting, where access to the source data and other information on the clients is limited by design.
Preserve my privacy, no matter how much you wanna know and how much you wanna see. It's how it's meant to be, we all want to be free. So stop for licenses, the ties don't break my privacy.